as a company, we want 5G to roll out everywhere as quickly as possible, as broadly as possible. So we're trying to help everyone finish in first place.
Gotcha.
There isn't really any second place.
Oh, yes, it's the Qualcomm Podcast. I'm PJ, and thanks for listening. Qualcomm makes some of the best technology on the planet. I'm going to bring you interviews with the experts and the inventors here so you can understand how the technology works and find out what's coming next. Today, we're continuing our conversation about Spectrum with our very special guests, Dean Brenner and Alice Turnquist. They're Senior Vice President and Vice President of Spectrum Strategy and Technology Policy here at Qualcomm, as well as Danny Tsang from Corporate Technical Marketing. I'm trying to keep this counter in my mind of a day where I don't see an article about 5G, and every day I see an article and it's about new services that everybody's going to offer.
Absolutely, and everyone's saying, hey, Qualcomm, are you going to make sure I'm going to be first? So, our job is to run a race here where basically everyone finishes first. We, as a company, we want 5G to roll out everywhere as quickly as possible, as broadly as possible. So we're trying to help everyone finish in first place.
Gotcha.
There isn't really any second place.
Were there any? What do you think were the biggest obstacles along the way with 5G? Was it more? Was it more just getting our partners, helping them prepare, or was this allocation of spectrum, was it actually was it kind of tough to roll that out at the beginning?
Oh man, PJ, so we can't talk about it in the past tense. So this is all happening today in real time.
Oh wow.
We haven't launched anything yet, and so we have tons of work to do, tons of work in the United States, tons of work to do in Europe and China and Asia
Wow.
and Australia and Latin America. I mean, on the spectrum part alone, we have tons of work to do. To get launched everywhere requires, a massive undertaking and really massive collaboration between governments and Qualcomm and all the partners who we work with. Because one of the things is, we're playing constantly a technical education role. So, regulators around the world have, they read the same articles that you're talking about, and so everyone wants to have 5G. A lot of people aren't exactly sure, well, what will 5G need to enable? What will it enable? But more importantly, what do I have to do in order to make sure it launches in my country or my region?
To that point, there's legislation pending in Congress that helps with the build-out of small cells, which are going to be really critical in the 5G infrastructure. And so there's legislation pending called Streamlined Small Cell Deployment Act that sets timelines for state and local governments to decide on applications for the placement of small cells. Because one of the concerns is that the federal government doesn't control completely this build-out process, and there's a lot of interaction with state and local governments. And if they don't respond in a timely fashion to requests to build out the small cell infrastructure, that could potentially hold things up.
Yeah. So PJ, what that's about is, the governments have zoning rules, right? You can't just put a 50-story building in a residential area, right?
Right.
So they have these rules for approvals that you need to get in order to build a new cell phone tower, a big 200-foot tower. But should those same rules apply to a small cell, something that's, the size of a router, or smaller than a pizza box?
Mm-hmm.
No, that doesn't make any sense, right? I mean, you wouldn't regulate those two things the same way. Well, each state, and in some cases each county, each city has to decide how are they going to regulate these small cells. And by the way, they have fees associated with them. If you want to erect a tall tower, you may have to pay a locality, a couple $1,000s to process your application. But if you want to put small cells in that area, you might want to put thousands of small cells. Should you be required to pay a couple $1,000s per small cell?
Mm-hmm.
How long will it take a city to process all the applications for each small cell? So this is a major, major logjam that we need to overcome for 5G.
And the small cells, these are basically mini cell towers that they would probably be delivering the millimeter wave type experiences. Is that correct?
Yeah, actually, so we have small cells today for 4G. Qualcomm makes chips, we call them the FSM chip, for small cells, for LTE small cells. They're not necessarily sold as small cells. I think Verizon sells a product that Samsung makes called Network Extender 2. T-Mobile calls it a personal hotspot. But these basically provide all the connectivity of a tall tower, but in in a very, very small, the size of a router. And they provide all the same connectivity, and they can provide coverage for as much as, I think, like 7,500 square feet. So this is an important part of improving 4G, but it'll be a key role for 5G because of millimeter wave, because we're going to need these small cells deployed in dense areas to get good coverage for 5G.
Right now, you guys are heads down, trying to help our partners and help the government expand this ecosystem. What do you think is after that? I guess stage one is to get these 5G networks up and running. On, I guess, millimeter wave would be the first deployment, and then you think kind of stage two they expand to different pieces of spectrum?
Well, again, the first in the United States, it'll depend on the carrier. Some of the carriers will deploy in millimeter wave first. Remember, I said Sprint will deploy in sub-6 gigahertz first. T-Mobile will, I think, probably deploy in both the 600 and in millimeter wave. But, I'm kind of smiling, PJ, because I don't know about you, Alice, but in my career, whenever I've worked on a big project, people have always said to me, well, what's going to be next? What's going to be next? And the implication is always, oh, you're all done. Well, we're never done. We're going to launch 5G, and then immediately there's going to be a demand for more spectrum. We'll come up with other ideas for things that we're going to want to do to make the experience for people better, to make mobile broadband faster, to improve the coverage, improve the connectivity. And it kind of all goes back to where we started. That's all going to require more spectrum, different parts of spectrum. So, we kind of never worry about what's next. We try to get through what's in front of us and, plan for what's next. But, you always have to roll with the fact that our technology experts are great in developing new technologies to do things that, today we never thought were possible. And that's hopefully that whole ecosystem is going to keep chugging along.
If you look at like when we launched 4G LTE, I mean, it was just a breakthrough in speed, but we continued to evolve that, and it's absurd how where LTE now is compared to when it first launched. I mean, the fact that it's cracked gigabit speeds is crazy. I think I remember the first our first LTE modem was doing about 100 megabits per second or something like that.
So, Dean and Alice, I have a question about how are we doing with 5G in the U.S.? Like, are we making good progress, getting spectrum open for deployments in the next couple of years? Is there anything that we could do better? What do you think?
First, I think we're doing well, but there's a lot we can do better. And that was the goal of my testimony, was to focus on the things that we're doing well, but point out the things that we can do better.
Testimony. Do you mind defining what was the event?
Back in July, I testified to the Senate Commerce Committee at a hearing they held about spectrum for 5G. There were 4 witnesses at the hearing: the president of CTIA, the Wireless Trade Association here in the United States. There was a technical person from Charter Communications, the cable company that's looking at getting into wireless, the president of the Satellite Industry Trade Association, and myself.
And there are 27 senators on the committee, Senate Commerce Committee.
Wow.
And I think they were all there at one point or another. They didn't all ask questions, but they all made brief appearances.
Where we're doing well in the United States is, we have spectrum that 5G is going to be launched on, the 28 gigahertz spectrum that was used for fixed wireless. Verizon is the largest holder of that spectrum. 39 gigahertz spectrum that was also used for fixed wireless. AT&T has some of that spectrum. The 2.5 gigahertz band, as I mentioned, with Sprint. T-Mobile has holdings both in the millimeter wave and in 600. So that's step one. Step two is for auctions. We finally have a timetable for the next several spectrum auctions. So there's going to be a spectrum auction in November of this year of some of the spectrum in the 28 gigahertz band that's in the FCC's inventory. After that, they're going to auction 24 gigahertz spectrum, and then in the second half of 2019, they're going to have a big millimeter wave spectrum auction for new millimeter wave bands. So I think that's all very positive, and is the result of a gigantic amount of work by the whole industry, Qualcomm, and the folks at the FCC, and the congressional leaders. Where a lot of people are complaining that we're sort of lagging a little bit is, so in that sub-6 gigahertz range, most everywhere in the world, 5G will be launched between 3 and 4 gigahertz. If you look at the spectrum allocations around the world, we have some spectrum allocated in that range, but we still have rules that are being debated at the FCC for that spectrum. So that's one problem. And then we really don't have enough of that spectrum, and the FCC is looking at how they can allocate more spectrum in that range. So that's a big part of the work that we have to do. And then the other big thing is what Alice was talking about earlier, is changing the rules to streamline the small cell deployments, because otherwise it's going to take way too long, and it'll be way too expensive for small cells to be allocated, so to get deployed because of the local, state and local zoning rules. So that's kind of our report card. So we're doing well, but we have a lot left to do.
The report card looking good.
Looking good, but a lot left to do. We have incomplete in a lot of subjects.
Great. So it seems like, but it seems like our partners are, they're not stopping. They're just ramping up. Everybody's just ready to. Yeah, they're just ready to roll this out.
And once it gets rolled out, of course, that's going to the momentum behind it will just increase exponentially, which will drive, much greater demand. This will go from becoming a hot subject to becoming a hot subject.
How do we make better use of the spectrum that we already have?
Yeah, so that's really been a guiding principle of Qualcomm from our very founding. All along, what we have always striven to do is to make better use of the spectrum for a whole variety of reasons, including the fact that, as we discussed earlier, spectrum is very expensive, so it's a very precious resource. We don't want to waste it. So the idea is to get the biggest bang for your buck, get the most efficiency out of every sliver of spectrum. So how are we doing that in 4G? Well, Wi-Fi is great, and we all use it all the time. But we actually took a look at Wi-Fi inside Qualcomm, and we have a Wi-Fi big Wi-Fi business at Qualcomm. Wi-Fi has a bright, long future. Right. But we started thinking during 4G, is there something we could do with this unlicensed spectrum that would even bring greater efficiency, more capacity, a better user experience than we can get out of Wi-Fi? So we came up with this idea that we would take some of the technical aspects of 4G, some of the attributes of cellular, and create a form of cellular that could be deployed in unlicensed spectrum. And that's what led to what we call LAA, or License Assisted Access. So what we do is, and none of us know it, this happens in our phone or in our laptop, and you wouldn't even know it, but your device is operating on both unlicensed spectrum and licensed spectrum, and the two are being aggregated together, bonded together, if you will, to create a bigger, fatter pipe to transmit data through, and for both downloading and uploading. And the results of that have been spectacular.
I think T-Mobile has been a big fan of it.
Mobile was one of the first big fans of it. Verizon and AT&T are all using it. They all call it different things. AT&T calls it 5G evolution. Mobile calls it something else. But it's not just this is not just a United States phenomenon. This technology, which Qualcomm led the way on, is being deployed all over the world. And this is something that there was tremendous resistance to in Washington, D.C., because some of the companies who are only into Wi-Fi, so you can think of cable companies and others who don't have licensed spectrum, basically said, oh, you're going to cause all these problems. This is my spectrum. This is Wi-Fi spectrum. There's no such thing as spectrum just for Wi-Fi. There's this unlicensed spectrum that as long as you comply with the technical rules, as long as you, in effect, are polite, you can use it for other things, including LAA. So we had to overcome tremendous resistance that was spawned at both through lobbying at the FCC and in Congress to say, no, wait a minute, this technology is going to be great. It's going to have double the capacity that Wi-Fi could have using the same amount of spectrum. And, consumers aren't going to know the difference. They're just going to know that all of a sudden their devices, work better. All of a sudden their mobile broadband is faster. All of a sudden they can get coverage in places that previously they couldn't get. So the results of this, as I say, in the United States and around the world have been spectacular.
That's great.
Now in designing 5G, we went back to the drawing board and said, okay, what can we do for 5G for this unlicensed or shared spectrum? So we're actually developing two different versions of 5G that don't just use the frequencies we've been talking about, these cellular frequencies that have to be auctioned, but can also use these other kinds of frequencies, unlicensed frequencies. And the results are tremendous. So we've done studies, we've done demonstrations showing that we can get 3 to 4 times faster speeds using these technologies that we have on the drawing board compared to what's available today. So we're very excited about it. This is a whole different part of our work that requires lots and lots of interaction with all different parts of the government in the United States and governments around the world.
Thanks for listening to the Qualcomm Podcast. And if you haven't already subscribed to our podcast, you can do so via SoundCloud, Apple Podcasts, and Google Podcasts. For even more news on Qualcomm technology, check out our Facebook page and Twitter feed. And by the way, my friends from legal really want you to know that references to Qualcomm may be Qualcomm Incorporated, Qualcomm Technologies Inc., and/or its subsidiaries.